Well, here we are at vectors. And the first question to ask is, of course, what is a vector? Well, when we measure quantities, there are two types of results we can get. The first is a measurement that has a quantity, but no particular direction. For instance, if I measure the length of a car, we may give the result in centimetres, but no direction is involved as the car is the same length no matter which way it's pointing. Similarly, if I measure the amount of energy stored in a battery, that is measured in joules, with no particular direction involved. Measurements that have quantity but no direction are called scalar quantities, or just scalars for short. But there are many quantities that have direction associated with them, and these are called vectors. For example, a car travelling along a straight road has a certain velocity in a particular direction, so velocity is a vector quantity. And if it's changing speed, its acceleration is also a vector, because this will be in the direction the car is travelling. Force is a vector. When you push something, you must push it in a particular direction. It's impossible to push something without a direction to your push being involved. Now, let's think about body weight, because this is a topic that most people get very confused about. I have a certain amount of matter in my body, which I measure in kilograms. The number of kilograms is related, of course, to the number of atoms in my body and the mass of those individual atoms. My body mass is the total sum of all those individual atoms. But there's no direction involved. My body mass would be the same whether I was standing on the Earth, floating around in space, or crashing onto the surface of Mars at 10,000 kilometres an hour. On the other hand, when I stand on the Earth's gravitational field exerts a force on my body which is measured in newtons and points towards the centre of the Earth. Because this force has a direction associated with it, it's a vector quantity, as we have already seen. I recently visited Toronto in Canada, and my son at the time was living in Perth in Australia. And if you look at a globe, you'll notice that those two places are almost exactly opposite to each other on the globe. So that means that the vector representing my son's weight towards the centre of the Earth was almost exactly opposite to the one representing my weight. Although I have to say mine was just a little bit larger than his. So there we are. In summary, if a measurement involves a direction, it's a vector. If not, it's a scalar.